Hello, Honors Algebra. Here is a review. It'll probably be in two parts. I got a feeling it's going to run long, so somewhere around 15 minutes I'll stop it and then make a second video, unless I'm really fast. All right, remember we solved compound inequalities. Now I'm not showing you how to solve simple inequalities because if you can solve a compound one, you can solve a simple one. So it has two parts, and I'll solve the left-hand part first. I'll add 2 to each side, and I'll get 3x is greater than 7. And then I'll divide by 3, and I'll get x is greater than 2 2/3. Or, okay, over here I'll subtract 1 from both sides, and I'll get 6x is less than or equal to 9, and then I'll divide by 6, and I'll get x is less than or equal to 3/2, or better said is 1.5. So, if I were to graph that on a number line, I would show 1.5. I would show 2 2/3. If I wanted to show other numbers, I could. On the 2 2/3, I have an open circle because it's not equal to, and I need numbers greater than it, so I'll shade to the right. And over here, I have a closed point, and I'm going to shade to the left because the inequality says less than. And there you go. If I test any number between those two, like 2, for example, I won't get a true statement on either one. I'll leave that to you to verify. All right, coming down here, multi-step equations. You know what? I should have put inequalities there. Silly Mr. Lawrence. And let me change this one to just a greater than. All right. Okay, first thing I'm going to do on problem number 2 is distribute and get 12x minus 3. That's going to be less than or equal to 10x plus 5. I'd like to get rid of my variable on the one side first. I usually get rid of the smallest variable. Okay, so I have on the left-hand side 2x minus 3 is less than or equal to 5. I'll add 3 to both sides. 2x is going to be less than or equal to 8, which means that x is going to be less than or equal to 4. If I was asked to graph that on a number line, that would be pretty simple. All right, over here on this one, I'm going to get rid of my smaller variable first, yielding 4 is greater than 3x minus 1. I'm going to add 1 to each side. 5 is greater than 3x. I'm going to divide both sides by 3. Okay. X is going to be less than 1 2/3. Remember that if I would have multiplied or divided by a negative, then this inequality would have flipped. All right, you may be asked to graph, and then you got to graph on a number line. All right, quickly review absolute values. Definition of absolute value, hopefully you can say the distance from 0 on a number line. Absolute value of 6 equals 6, because 6 is 6 spaces from 0 on a number line. Absolute value of 0, that's an easy one. It's 0 spaces from itself, so therefore the absolute value is 0. And 6 says the absolute value of negative 3 plus 1. That's the same as the absolute value of negative 2. How many spaces is negative 2 from 0? Why, it's 2 spaces. Okay, remember the distance from 0 on a number line. Okay, let's try this equation, absolute value equation. I'm going to get 2 problems, and this is where Vinny's little thing, I'm not going to do it on every single problem, but he seemed to really like it, and it was a good visual. So I'm going to do 2x minus 6 equals 10, and then 2x minus 6 equals negative 10. All right, I'm going to add 6 to each side. We're going to get 2x equals 16. And then I'm going to divide each side by 2. X is going to equal 8. That's one of my solutions, and I really shouldn't have circled that because I want to get both solutions, don't I? Dividing by 2, x is going to equal 8. Or, put my or in here, he's very important. I'll add 6 and add 6 and get 2x equals negative 4. Divide by 2, divide by 2. X is going to equal negative 2. And there's what I should circle that as my solution. All right, number 8 is an and, a less than, right? Remember, less than is on your left hand. And I like to do them as one sentence. So I'm going to do 5x minus 2 is less than or equal to 11. And negative 11 is going to be less than or equal to 5x minus 2. I add 2 in 3 places. And that gives me negative 9 is less than or equal to 5x, which is less than or equal to 9. No, 13, silly me. Okay, that's a 13 there. All right, and then I divide by 5 in 3 places. And that gives me negative 1 and 4/5, which is less than or equal to, oh my goodness, did you see that mistake? Wow. I'm not sure, I must have been hallucinating. I apologize, ladies and gentlemen. Let me start this over. Negative 11 is less than or equal to 5 minus 2x, which is less than or equal to 11. Sorry about that. Okay, so I'm going to subtract 5. Why am I subtracting 5? Because a 5 is positive, and to get rid of it, I have to subtract. So I'll get negative 16 is less than or equal to negative 2x, less than or equal to 6. And then I will divide by negative 2. What's that? I'm dividing by negative 2. Huh? Divide by negative 2. What kind of 2? A negative 2. Why did I repeat that so many times? I'm going to get 8. I'm going to get x. And I'm going to get negative 3. But my inequalities are going to flip. And there we go. Of course, if I graph that on a number line, I will get an and picture, right? I'll get myself a little more room here. All right. Get a negative 3 over here, positive 8 over here. And there we go. All right, how am I doing on time? I'm already at 8 minutes. That's not too bad. Okay, so on number 9, I'm going to get 3x plus 1 greater than 16, or 3x plus 1 is less than negative 16. This is one where Vinny could use his little tree trick if he wants. Okay, it's a very cool trick. I'm going to subtract 1 and get 3x is greater than 15. Divide by 3, divide by 3, and get x is greater than 5. Or subtract 1 from both sides, get 3x is less than negative 17. Divide by 3, divide by 3, you get x is less than negative 5 and 2/3. Negative 5 and 2/3. To graph that on a number line, I'm going to have 5 on there. It's going to be an open point at 5. We have negative 5 and 2/3. Might want to show a 0 in between. That's fine. That's also an open point. I know it's an or. It's going to go like that. Okay. Numbers 10 and 11, that's where I have to write the inequality. Remember, first I'm going to find the midpoint. And it looks like negative 2 plus 4 divided by 2 Looks like that'll be 2 divided by 2, which is 1. What would make my expression turn to 0? I need 1 to make my expression turn to 0, so that must be an x minus 1. I know the picture looks like an or. It's not equal to because my points are open. And here's my midpoint. How far are my endpoints from my midpoint? Well, they're 3 spaces. There you go. Pretty simple stuff. Okay, number 11. I've got -3 to +3. Looks like my middle is 0. My midpoint is 0. That's an easy one. Absolute value of x like that. It's an and it's also equal to. And how far are the endpoints from 0? In this case, they're 3 units. There you go. All right. Let's solve these absolute value inequalities, which will take almost no time at all. I'm not going to do all this work. If I do all the work, I'm going to get a strange answer. Check this out. This absolute value is less than 0. Do you know any distances that are less than 0? I don't either. This is going to have no solution. Now, just to prove that I'm right, I'll go ahead and solve it the long way. It's an and. Okay, and I'm going to get 2x is less than 5. All right, and going to get a 5 there. And when I divide by 2, I'm going to get 2.5 is less than x, which is less than 2.5, which should seem really, really strange to you. Okay, so maybe you're thinking the answer is 2.5. Well, if I plug 2.5 here, 2 times 2.5 is 5. I get 5 minus 5. Is that 0? Of course it is. But the absolute value of that equals 0. It's not less than 0, is it? No. There is no solution to this problem. I could have told that by just looking and seeing that my distance had to be less than 0. Remember, the number out here is the distance. And that's what we did on these problems, right? These are the distance from the midpoint, right? How far are those from the midpoint? Well, 3 units. This is how far the endpoints are from the midpoint in problem 10. 3 units. Well, this one, the distance has to be less than 0, meaning it has to be a negative number. There is no solution to this. All right, on this one here, I need my distance to be greater than -2. Aren't all distances positive? Sure they are. I'm going to get all real numbers on this one, but I'll prove it to you. I'll go 3x plus 1 is greater than or equal to -2, or 3x plus 1 less than or equal to +2, excuse me. Okay, subtracting 1, and I'm going to get 3x less than or equal to 1, divide by 3, divide by 3, x is going to be less than or equal to 1/3. Okay, on a number line, I'm going to have 1/3. Now we have an open point, and I'm going to shade this way forever, right? Okay, let's see what happens up here. I'm going to subtract 1, and I'm going to get 3x. It's greater than or equal to -3, which means x is going to be greater than or equal to -1. So I put -1 on here. It's going to be an open point, and I shade this way forever. And since it's an OR statement, I only need one part of it to be true. I end up shading the entire number line. So this is all real numbers. Okay, I'm going to stop this video here, and I'll post the other part tomorrow night. Well, actually, maybe I'll just post both parts, and you can watch them at your convenience. All right, Mr. Lawrence signing off with part 1 of our review video.